Okay, so let's talk about the slope-intercept form of a line. Now, I showed this a little bit in a previous video, but now we're actually going to see what it is, how we can use it, and especially how we can write the slope, how we can find the slope. Basically, a linear function written in slope-intercept form will look just like this: y equals mx plus b, where m is your slope and b is the y-intercept. Okay, so we're going to figure out how to find those in a second, but that's what you have to know. M always represents the slope, B is the y-intercept. I have no idea why they chose M for the slope, but there's a couple theories out there. I have no idea. But basically, in a nutshell, the slope tells us how steep a line is, and the y-intercept is really just where the line, or any function, crosses the y-axis. So that's really just what is the y value when x equals 0. Okay, those, again, that's a nutshell. We'll talk more about that in a second. So let's figure out how we can actually find the slope of a line. Okay, so like I said before, the slope basically tells us how steep a line is. It basically tells us what is the relationship between two variables that are being graphed, usually the y and the x. Now, the formula that we use, the first one that I ever learned and that I still pretty much teach to everybody, is it's rise over run. I'll show you what that means graphically in a bit, but what that means is it's the change in y divided by the change in x, and what that really looks like math-wise is the ugly one right here, y2 minus y1 over x2 minus x1. So if you look, this is how to find the slope between two coordinate points. You have to have 2 points. Okay, we can create a line between any 2 points, and this will tell you the slope between them. Okay, so let's put this into practice. If you look here, we still have the formula up here. I want you to memorize these. This one's the most important for when we find the slope between two given points, but here I want to show you what it looks like graphically. So the rise means, let's say we're finding the slope between the 2 points A and B. So what I would do is I could start at A or I could start at B. I'm going to show you that it works both ways. All right, that's really important for this one. But let's start with B. The rise would be this value right here, and the run would be this value right here. So the change in y is the vertical change. I really should have put that up here. Vertical change, and then that's the same thing as the change in y. But the vertical change right here, if you look from B to A, it looks like it's 4 units. And if you look at the horizontal change between B and A, that looks like 2 units. So the change in y is 4. The change in x is 2. 4 divided by 2, that's just 2. And if you notice, I actually gave us the equation over here just so we could check. If you look, this is actually in slope-intercept form. Y equals m times x plus b. Well, let's check. 4 divided by 2, that's just 2. So the slope of this line is 2, and the y-intercept is also 2. That y equals mx plus b value, well, the b also happens to be 2. And if you remember, I showed you a very quick snippet of it, but the y-intercept tells us where the line crosses the y-axis. So this positive 2, that's where that came from. But I also want you to remember that the y-intercept is the value of y when x equals 0. So if I were to plug in 0 up here, I would get 2 times 0, that's just 0, plus 2. Y would equal 2. That's a 2, by the way. And that's exactly what we got. So you'll see questions like these in the future where it'll give you a slope and it'll give you the intercept and it'll tell you, okay, graph this line. And that's all you do. You say, okay, well, I know the y-intercept, that's just 0, 2, and I know the slope, oh, that means I go, up 2 over 1. And we'll talk more about that in a bit, but what I want you to realize as well, and I've spent too much time on this problem, I apologize, but 4 divided by 2, we said that's 2 divided by 1. That means I could do that as well. I don't have to go up 4 over 2. I could go up 2 over 1 because that's still equal to the same thing. These are both equal to each other. So up 2, let's pick another point randomly, over 1. And if you look, this point that I randomly came to when I started at A is also on the line. And just to show you what I meant when I said we could go from B to A or A to B, I could go down 4 and left 2. Down 4, that's negative 4. Left 2, that's negative 2. Negative 4 divided by negative 2, that's still positive. So that's still a positive 4 over 2, okay? So that's kind of how we can look at a line and do the quick and easy way for finding the slope, the graphical way, just figuring out what the vertical distance is and what the horizontal distance is. And we'll definitely get more practice with these. I've posted problems in the description box, so click on that, it'll take you right there. But let's try another way of finding the slope. Okay, so now you'll see this very often. It'll say, all right, what's the slope that connects these 2 points? Or given these 2 points, find the slope of the line between them, or, there's multiple ways that we could word it. But this is where this equation comes in. Okay, so really all I want you to do is pick one coordinate point and pick that to be your x1, or sorry, x2, y2. So let's pick it right here. This will be x2, y2. So I'm going to put 2 minus the other y value. So that's y2 minus y1. So we'll do 2 minus 8. That's our two y values. And we have to go in the same order. So I started from here to here. I go from here to here for x. So 2 minus 8 over 1 minus 4. And let's see what we get. Negative 6 over negative 3. We get a positive 2. Now let's go backwards. I want you to know that we can get the same thing regardless of which way that we go, as long as we go in the right direction each time. What I mean by that is if you go from left to right, go from left to right with the x's. So let's pick 8 first. Instead of 2 minus 8, let's do 8 minus 2 and see what we get. 8 minus 2 over 4 minus 1, we get positive 6 over positive 3. And if you noticed, that's still a positive 2. So we get the same thing regardless of the order that we go in. That's a really important thing to remember, especially when we're looking at these graphs. Okay, so we've looked at how to find the slope from a graph. We've looked at how to find the slope from a couple of points. This table is very similar to the last one. We've actually got a few points of xy coordinates that we could pick from, but we still do the same thing. But what's nice about the table is you can actually look and see what the difference is. So if I go, let's say I pick this point, 1, 3 and 3, 7. The change in y would be positive 4. The change in x, and I probably should have moved this, is positive 2, if you could see that. And what we do is the change in y, which is 4, divided by the change in x, which is 2, and that's just 2. Now, this is a line. These points all represent points that are on a line, so I should be able to pick any 2 points and still get the same answer. But let's double check that. So we did that one already. Now let's go and try, let's say we pick 3, 7 and 9, 19. So the change in y is from 7 to 19, that's a positive 12. From 3 to 9, that's a positive 6. I'm just going to write it up here. And then the change in y is 12, change in x is 6. Well, 12 divided by 6, that's still 2. That's the same thing that we got in the beginning. So that's one thing that's very important. It doesn't matter what points that you pick, the value is still going to be the same. The value of the slope is still going to be the same. So far in this video, we've been finding the slope using a graph, using a table, given 2 points. Now we actually want to graph a line, given a formula that's in slope-intercept form already. And remember, the slope-intercept form is just y equals mx plus b, okay? Where m is our slope and b is our y-intercept, where our line crosses the y-axis. So if I look at this line, it looks like, I want you to take a look at this and try it out. But it looks like the slope is 3, and it looks like our y-intercept is -1. Now the reason why this is so convenient is because it makes it really easy to graph. If I have the graph over here, I can plot our y-intercept at -1, and then we say, okay, well, if the slope is 3, that's the same thing as 3 over 1. So my vertical change is 3, that's a positive 3, 1, 2, 3. My horizontal change is 1, that's a positive 1, so I go over 1. And that's it. That's another point that would lie on this line. And I just connect those two, boom, right there. That's the line y equals 3x minus 1. That's the graph for that line. Okay, and if just in case, if I plug in 1, 2, this random point that we just got, 1, 2, when x is 1, 3 times 1 is 3, 3 minus 1 is 2. That's it. So that's the solution as well. And that's it. All you need is 2 points to graph a line. So that's the really convenient thing about the slope-intercept form, is it gives us a point, 0, -1, and then it tells us the slope. It basically tells us how we can get to another point. I could go up 3 to the right one, I could go down 3 to the left one, and if you look, I try to draw this line so that it would work. That's another point that we have. And that's really the gist of how to graph a line that's in slope-intercept form. Figure out what the slope is, what is the y-intercept, graph that, and then you can find your next point from the y-intercept using your slope. That's the very convenient part about this. Why we love the slope-intercept form of a line. It's the most popular form that we use. Okay, so let's try another example. Work through this one and then we'll work on it together. Okay, so looking at this, it looks like our slope is -3 over 2. And our y-intercept, nope, not y, b, our y-intercept b is +1. So what I'm going to do is graph 1. That's where our line crosses the y-axis. And our slope is -3 over 2. So this was what tricks up a lot of people. This is either -3 over +2, or it's positive 3 over negative 2. Both of those are perfectly fine, and I'll show you what both of them would give us. So let's say I use this one right here. That would be down 3 and right 2. So I go 1, 2, 3, right 2. There's 1 point. And let's say I use the other one. If I use the other slope, 3 over negative 2, that means I go up 3 and left 2. And if I put these all, hopefully it gets on one line. Kind of missed that. So that would give us our line though. And again, we only need 2 points to graph a line, and then we just connect them. I just wanted to show you we can use either one. And I mainly wanted to show you that what a lot of students will do is they'll put the negative on both of these. Don't do that, because 2 negatives divided by each other gives us a positive. That would be wrong. You would get that wrong, and it happens all the time. So make sure you pick one. Either put the negative on top or a negative on the bottom. But it works for either one, okay? And that's pretty much it for how we graph lines that are given to us in slope-intercept form. We spent a lot of time with how to find the slope because that is a very important topic in this class. We're going to move in the next section into how we actually look at word problems and come up with equations for them. But you need to know what the slope is, and you need to know how to graph a slope that's given to, or graph a line, graph a line that's given to us in slope-intercept form. So hopefully this video was helpful. Make sure you try the practice problems in the description box, and we'll see you in the next video.